I wanted to help you guys as you're studying to go through several problems that are very similar to the ones in your test and help you see, based on what the problem asks, what should you do. So I'm not going to work all these problems out. I'm just going to go through the instructions for each one and try to help you see, oh, okay, so that's how I need to approach that. Let me adjust this just a little bit. All right, very good. Now, it says in number 1, use the properties of logarithms. So as soon as I see that, I know I'm not concerned with a derivative or an integral. It just tells me, use the properties of logarithms. That's where we go through those 5 rules. Natural log of 1 is 0. Natural log of e is 1. If you're multiplying, you can split it up by adding. Dividing, split it up by subtracting. If there's an exponent, you can move it out front as a coefficient. So that's the idea here, or it would be in reverse actually from what I just said for this one because you're condensing. You'd move the coefficients up as exponents, you'd change the adding into multiplying and the subtracting into dividing. So that's how we'd approach number 1. Now number 2 says find y prime. So y prime means the derivative. So I know because I see y prime, I'm taking a derivative. And it says e cotangent x, so that tells me that I'm going to be using the rule e to the u du. I'm going to be doing itself times the derivative of the exponent. I know that because it's e. And the derivative rule for e is e to the u times du, or itself times the derivative of the exponent. Let me scroll down here. So number 3. Find the slope of the tangent line to the graph of y equals natural log of x squared at the point where x equals 5. So it says find the slope. Well, in calculus, we find slope with the derivative. So I would take the derivative of the equation y equals natural log of x squared. And because it's natural log, I know my rule would be du over u. Or you could say the derivative of the inside over the inside. Then once I get that, I would plug 5 in for x. Number 4 says find the integral, and it shows the integral sign. So that tells me I'm doing an antiderivative. And I have e, so I'll be using the rule, since I just have one e, that u, when I do u substitution, pretty much all the integrals will use u substitution, but since I have one e, I would know that u would need to be equal to the exponent. U, for that problem, number 4, would need to be 4x squared. Now number 5 changes gears on us. It says find y prime. That means find the derivative. So we would take the derivative of e to the 3x minus x to the 4th. And I know the rule for e is itself times the derivative of the exponent. Number 6 would be the same. It says differentiate, that means take the derivative. There's again an e, so I know the rule would be itself times the derivative of the exponent. Number 7, similar, says find dy over dx. That tells me I need to find a derivative. So finding y prime, finding f prime, differentiate, find dy dx, all those mean the derivative. So I would see 2 things as far as my strategy here. First of all, since it's e to the x times x to the 4th, you would need to use the product rule. Second, because there's an e to the x, I'll need to use the e rule, which is e to the u times du, or itself times the derivative of the exponent. Number 8 says find an equation for the tangent line to the graph of this equation at the point 2, 1.6094. Now, it says find the equation for the tangent line. For the equation of a line, you need 2 things. You need a slope and you need a point. The point is given to you. It's that 2, 1.6094. That's your point. You also need the slope. Slope in calculus is found with the derivative. So we would take the derivative of that natural log of x squared plus 1 using du over u, the derivative of the inside over the inside. Then we would plug 2 in for x, and that would tell us the slope at that point. We could then use the slope and the point to write the equation of the line. Number 9, it says differentiate. That means we need to take the derivative. Two things there. We have 6x times the natural log of x squared plus 3. That tells me I need to use the product rule because I'm multiplying two functions together. And I'll need to use the du over u derivative rule because it's the natural log. So for the derivative of the natural log part, we will use the derivative of the inside over the inside, du over u. So number 10 is very similar, but actually a little simpler because there's no product rule here. It's just the natural log. So we're told to take the derivative. That means we'll do the derivative of the inside, 6x minus 5, over the inside, 3x squared minus 5x. Okay, number 11 says expand the logarithm using the properties of logs. So again, I see properties of logs. That tells me, oh, okay, I don't need to do any derivatives or integrals here. I just use the properties. Use the properties allow me to split it up or expand it. I change multiplying to adding. I change division to subtracting. I change exponents out to coefficients. 12 says find dy dx. So that tells me to find the derivative. Just a recommendation to make it better for you, that cube root can be rewritten as an exponent of 1/3, which you can then bring out front as a coefficient. So you can use the properties in this case to make the derivative easier. By doing that, you'll avoid having to use the chain rule, but you'll still need to use the natural log rule, which is du over u. And by the way, I'm sorry if it seems like I'm going fast. I'm just trying to make this not too long. You can always pause or rewind and listen again if you need to for an individual problem. But this one says find dy dx, meaning find the derivative, and it's natural log, so I'll use the derivative of the inside over the inside, or du over u. 13, same way, says find dy dx, meaning find the derivative. I would start by using the properties to split that up, and then take the derivative of each piece using the du over u rule, which is the derivative of the inside over the inside. Now for 14, we have an integral. That's what that symbol is right there. It's an integral. There we go. That symbol right there. That's an integral, meaning we take an antiderivative. So I will need to use u substitution, and in this case, I would use u equal to the bottom. Remember, unless there's an e, u is going to almost always be something inside of a power, inside of a radical, inside of a trig function, or something inside a denominator. In this case, you would use the secant x in the denominator. 15 says find the derivative. So that tells me clearly to find the derivative of number 15. It's a natural log, so I'll need to use du over u, the derivative of the inside over the inside. Now I would highly recommend on that one, use the properties to expand it first. You don't have to, but it'll make the problem a lot simpler if you do. So expand that log using the properties, then take the derivative of each individual piece using the derivative of the inside over the inside. 16 says find h prime. That means we're finding the derivative. And the rule for e is itself times the derivative of the exponent, or e to the u times du. 17, evaluate the integral. And we've got another integral sign that's real clear right there. So that tells me I'm taking the antiderivative. I need to use u substitution. And u would be equal to the denominator, x squared plus 1. Number 18 is actually the same. It's written a little bit funny. You won't have one with that vocabulary on your test this time around. It would just say evaluate the integral of this. And to evaluate the integral of 4x over 3 minus x squared, you would again make u equal to the denominator, 3 minus x squared. On both 17 and 18, you'll end up with du over u. Now once you end up there, you know the rule for du over u is the natural log of the absolute value of u plus c. 19, same idea. You'll use u substitution because you should use u sub when you're doing an integral or an antiderivative. U is equal to the denominator. Then you'll find the du, it'll be equal to the top. So then du over u becomes the natural log of the absolute value of u plus c. 20, we're told to differentiate. That means take the derivative. So the derivative for e is itself times the derivative of the exponent, or e to the u times du. 21 says evaluate the integral. So that tells us we're doing antiderivative. We have an e, so our u should be the exponent, 1 over x. 22 says find f prime. That means the derivative. And for natural log, the derivative rule is du over u. So the derivative of the inside over the inside. 23 is the same. Find the derivative. So I would recommend you use the properties to bring that 4 out front as a coefficient. Then take the derivative of the inside over the inside. 24 says evaluate the integral. That means we're doing u substitution because it's an antiderivative. And since there is an e in just one of them, you should make u equal to the exponent. That means u would equal sine of x. Alright, lastly, these 6 questions will be on your test. I don't know if it'll be that order or not. I don't have it memorized, but it will be those 6 questions. You need to know the antiderivative of these 6 trig functions. Please make sure you have that memorized. You can do this. Review the rules, make sure you know them well, make sure you have it clear in your head what the derivative rules are and what the integral rules are. You guys can do this. I really believe that. You can do great.